First things first, I wanted to make a retraction and give a shout out to Bev Try Thinking channel. I was on his show the other day and I made the claim that 2 pi d squared is the same as 4 pi r squared, and I was wrong. I forgot what it was, but so I'm showing here that 4 pi r does equal 2 pi d, but when you square it, it's not the same. But what I just forgot and meant to say, which should have said, is 4 pi r squared does equal pi d squared. So I wanted to get that out of the way. Shout out to Bev and crew, and I got some pretty cool stuff in this video showing where the surveyors claim that the surface of a sphere is not two-dimensional, and I want to show where I think the deception lies in these equations.
System is used to express relative directions, rather than for expressing exact positions on the Earth. For that, we need a position reference system where each position is precisely and unambiguously defined on the Earth's surface. An example of a position reference system is the Cartesian system. In this case, two reference axes are used, with which it is possible to express any position precisely by means of Cartesian coordinates. For example, if we want to express the position of this red point, we can observe that it is located at 4 units on the x-axis, and at 3 units on the y-axis, so the Cartesian coordinates for this point would be x4 and y3. So using these axes as reference, we can accurately and unambiguously express the position of any point within the scale, as we can see here. However, something important to keep in mind is that this Cartesian system only works on a two-dimensional surface, so it could not be correctly applied to the Earth, since it is a three-dimensional sphere. This Cartesian system only works on a two-dimensional surface, so it could not be correctly applied to the Earth, since it is a three-dimensional sphere. However, something important to keep in mind is that this Cartesian system only works on a two-dimensional surface, so it could not be correctly applied to the Earth, since it is a three-dimensional sphere.
So what do we get from this tutorial? Okay, this mathematician thinks he lives on a sphere. So he tells us that the two-dimensional Cartesian coordinate system doesn't work on the surface of Earth. It only works on a two-dimensional surface. Okay, so he's been tricked, but he still knows that the surface of a sphere is not two-dimensional. Once you move up or down in free space, you've added a dimension. There's no getting around it. But they have to have a two-dimensional surface with their maps, or otherwise their measurements don't prove a sphere.
Cartesian system only works on a two-dimensional surface, so it could not be correctly applied to the Earth, since it is a three-dimensional sphere.
This is the whole trick, people. They take and map the ground on a 2D Cartesian coordinate system, then use mathematical transforms to turn it into a sphere, and then try and use the measurements to say they prove a sphere. So now we have exposed the deception, or the mistake, take your pick. Will they still go out and perpetuate the trickery? Because this is the second time I've showed them their own surveyors and map makers stressing the importance that the surface of a sphere is not two-dimensional. They know that if they admit the surface of their sphere is three-dimensional, then they lose their proof. Then it could be flat also. In reality, we know it could be flat because it's measured as flat, two-dimensional Cartesian coordinate systems. So question, is your celestial sphere two-dimensional? Because it's got to be, right, in your world? So just in case they try to say, well, 3 dimensions is the volume, let me cover that base. I can already see them making a video. So listen carefully, ballers. If you consider a circle and a sphere, both are round. The differences between the two shapes is that a circle is a two-dimensional shape and a sphere is a three-dimensional shape, which is the reason that we can measure the volume and the area of a sphere. So just because it's not the volume, once you leave a circle, you leave the second dimension. Enter the third dimension. Okay, so we get the area of a circle that we talked about, 4 pi r squared or pi d squared. And it's same thing with a cube. You can get the area of a cube surface or the volume. Once you leave the square, it's 3 dimensions. Okay, I'm going to show you why they have it set up the way they do. Okay, so 6 squared, that's 2 dimensions. 6 times 6 is 36. That's 2 dimensions. If we add another function to that, we are adding another dimension. So that's for a square. Now let's try it on a cube. Okay, so 6 times 6 times 6 sides gives us the area of a cube of 216 square foot. So 6 times 6 squared, right? It's the same thing. So just to show you, double check. 10 squared is 100. That's your square, 2 dimensions. Now times 6 sides gives you this cube of 600 square feet area. So 6 times 10 squared is 600. So by adding the extra function, you're adding another dimension. This is what they do with a cube. With a circle. They tell you 4 pi r squared is the area of a sphere. Why don't they just tell you pi d squared? It's the same as 4 pi r squared. I was saying 2 pi d, and I was wrong about that, but it's actually pi d squared. Okay, I'm going to show you in a minute. But pi times d is the area of a 2-dimensional circle. Pi d squared is adding a dimension. So let's test it out. So if the radius is 3, then we know the diameter is 6. So we're going to do 4 pi r squared, 113.097. Now we'll try it with the diameter. So pi d squared is also 113.097. Same shit. So just to show you, 6 is the radius. So we're going to go 4 pi 6 squared, 452.38. So we'll try it with a diameter of 12 instead of 4. Just regular old pi d, pi 12 squared. Also 452.38. Same shit. So they're adding a step here. Now one more just to show you that it's consistent. 9's the radius. So 4 pi r squared, 1017.876. So once again with the diameter, pi d squared, 1017.876. Same shit. So you see this, y'all? It's obvious if they add the squared to add another dimension. So they switch it up to 4 pi r squared because pi d gives you the area of a circle. Once again, that's 2 dimensions. Pi d squared gives you the area of a sphere, 3 dimensions. They've added a dimension by squaring it.